You guys have frost on your cars today? If you were outside? Had to do a little scraping? Oh, it wasn't that thick of a frost. Pretty soon you're going to have to get up a little bit earlier so you can scrape and warm up your car up outside. If you're fortunate to have a garage and you don't have to worry about that, but I bet most of you are not going to be able to drive and you don't have that chance. So. What's that?
If you're really risky enough, you can drive at the same time. You just gotta.
Yeah, I don't remember. I go into the sun from my house, so that's really not an option there.
You just gotta hope that you can see the blue before you run into it.
It's better that you get up early and scrape your car and then warm it up so you don't have that fog on there. All right.
That dark blur, is that a tree?
Yeah.
Be careful.
Molar mass. All it says, this is the weight of 1 mole of the substance. And 1 mole is a certain number of molecules or atoms. And that number is 6.02 to the 23rd. Okay? So, we've done this before. This was on the assignment before this last one. And you had to go through. In fact, some of you didn't hand it in. You probably need to hand that in. And you were asked some questions about how many moles of a certain element that's within a compound. Okay? So, the first thing I'm going to ask you, and I'll ask a couple people, and these aren't very hard questions, so I'm going to ask a couple of you in here to give me an answer, because it's based upon the assignment today a little bit. Okay? Brooklyn, when you look at lead, what's the molar mass of lead? PB. 207.2. So this question mark is not a question mark anymore. It's 207.2 grams per mole. Okay? So another question, Sadie, what's the molar mass of oxygen?
15 or 16.
Yes, good. She kind of recognized that she doesn't have to go out so far. And when I told you guys, you just need to go out to the nearest 100 spot is fine. So that's 16 grams per mole. Some of these you're going to memorize. Well, some of them you're going to use so much, you just know them. Okay? And oxygen is going to be one of those. Okay? So I've got this compound, and this compound, I want to know the weight. I want to know the molar mass of 1 mole of PbO2. So if I want to know how many grams per mole I have of that compound, then I have to break it up, and I have to find out how much I have of everything in there. Okay? Colton, how many leads do I have in PbO2?
1.
1 mole. So I got 1 mole of lead. All right? Brett, how many moles of oxygen do I have? 2. 2 moles of oxygen. Any questions on that? Okay? Now they could be a little bit tougher. Sometimes we'll have parentheses. But everybody knows how to count atoms. The thing is, I want to know the molar mass, or how many grams make up a mole of this compound, PbO2. All right? So I count how many moles I have of each thing. And then what I need to do is I need to add those up. So what I'm going to have to do is I'm going to have to multiply this by its molar mass, the 2 moles times its molar mass. I'll get 2 answers. Each one of those contribute to the overall weight per mole of that compound. So I'm going to put 207.2 grams per mole. And then here, it's 16, just like I asked you guys. Alright, so this is 207.2 grams, and this is 32. So then when I add those together, it's 239.2 grams per mole. Any questions you have on that? That's all you do. That is all you do. You count how many you have. You know that each one has a certain number of moles that they contribute to the overall mass. You find their weights, their individual weights, and you add them all up. Okay, it's kind of like having a car, and this is a real simplistic example, but if you want to know the weight of the car would be, and let's say that the tires and wheels are off, the 4 tires and wheels are off, you know the mass of the frame, you know the mass of all the individual tires. You could take the mass of the frame plus the 4 tires, their weights, and when you add them together, you get the total mass of the vehicle, for example. That's not probably a great example, but that's kind of what we're doing here. So, I'm going to have you, that would be 239, that would be answer. So, for a lot of problems you guys do in here, this is a step you're going to always do. This step right here, for a lot of problems, you're going to do. Okay? And some of you are going to get really fast at doing these, because you're not even going to look them up, like oxygen, you'll know what those are. Some other elements, and it'll be a quick process, and it's a pretty simplistic process, I think, when approaching and doing these type of problems. Okay? Alright, I'm going to have you find a molar mass for me. This one's a little bit tougher to do, but I'm going to go ahead and have you find a molar mass. A molar mass here. I got to find out my order here. Did that one already. Okay, go ahead and find the molar mass of this one. 1 mole of ACl3. Okay, so I'll give you a lot of time on that. We have 1 mole of aluminum and 3 moles of chlorine. We look up aluminum and it's 26.98. We look up chlorine and it's 35.45. So we multiply 1 times 26.98. We multiply 3 times 35.45. Then we add them up. We get 133.63. That is all you needed to do. Questions on that?
Can we be off by like a certain
You can. I mean, if you're rounding, everybody's rounding properly. In this example is probably pretty easy because aluminum's pretty easy to round to the 9/8 because it's 9815, and then chlorine is actually 35.45. That's what it actually is. So on this one, I would think pretty much everybody would have came up with that answer. Okay, and just go 2 places to the right when you round. So to the right of the decimal, just go 2 places to the right when you round, and we'll pretty much, everybody will be on the same page when we do that. Okay? Any questions you have with that? All right. So that's the new stuff today. Okay? Now we're going to combine the new stuff with the old stuff. All right? And so here's a question that will be asked that is the new stuff. So we're combining 2 concepts, all right? And then it's not that tough. We're combining what we did yesterday, converting, or Friday to today. We're converting moles to grams or grams to moles on your assignment with elements. Okay? Now we're saying, okay, we don't have elements, now they have compounds. So the first step you would do on any problems, the first step you did like on this ALCL3. You went through, you figured the mass, okay? And then you got your answer. And so what we need to do is change the moles into grams. I want to see if you can do that on your own without any help. So look at the problem. The first step's already been done for you. Normally the first step you'll have to do on your own. You'll have to know that if I'm going to find out how many grams are in 4.25 moles of a sample, I've got to find out how many grams are in a mole. So the first step you're going to have to realize you're going to have to be able to do. You guys will probably like these problems. They're not that difficult, and we do them a lot. I mean, it's a main focus on doing a lot of different types of problems this first semester has to do with these type of questions. Okay. I'm going to show you the answer. I'm not going to write it out because I did this first period and I have the answer written out. So I'm going to give that here to you. All right, here's the answer. Here's the setup. Questions? See, it's the same thing as we did for today. The only thing that's different is we have to go through and calculate the grams in a mole. So I have a lot of people ask me questions, do you multiply by that number and divide? Every year I seem to have that. Well, your units tell you what you're going to do. If you have moles, then the 1 mole will go on bottom and you got to find grams. Okay? If you're given grams, then that weight goes on the bottom so you can cancel out grams to go to moles. Okay. Now, I'm going to give you a problem. Okay. And I'm going to base it on our first example that we did, since we have a molar mass of our first example, PbO2, right? So we've got a first example of PbO2. And we figured out the mass of PbO2, so I'm going to go ahead and give you a problem based upon that weight so that you can do it. Okay. Okay, determine the number of moles of PbO2 found in 125.1 gram sample. So when you're counting these all up, 10 you have 1 mole, carbon you have 8, hydrogen you have 12, and oxygen you have 8. So when you set this up, you've got 1 mole of 10, you got 8 moles of carbon, 12 moles of hydrogen, and 8 moles of oxygen. Then you just have to find their weights. Multiply them, then add them all up. Okay, when you get the answer, you can look up here to see if it is the same. So you just take each of those moles, total count, time their weight. Now, carbon, you'll get to where you memorize it, it's 12.01. A lot of them are 01s, like carbon's 1201. Hydrogen's 101, nitrogen's 14.01. So a lot of them are really, some of them are whole numbers, like helium is 4.00, oxygen 16.00. So it makes it a little bit easier to do those. Okay, so the assignment I'm going to give you is on that same page of 205. Just add this assignment to the one we just did. There's 6 of these you're going to do. So page 205. And I'm going to have you do, you can check your answer on the odds. So that's probably a pretty good thing to do as you go through. 23D and then 24DE. And then 25E and 26DE. There you go. And those are really similar to what we did. Have that done for tomorrow. And we'll have you just turn that in. I'm probably not going to take too many questions unless we can take that first couple minutes, and then we need to move on to what's called percent composition a little bit tomorrow. Okay?